It's time for your Heli Life giveaway secret word. Listen up and remember this word because you'll need it to enter for a chance to win exclusive Heli Life gear. Ready? This episode's secret word is RPM. Visit contests.verticalhelicasts.com to enter the secret word.
All right. Welcome to the Helicopter Podcast. I'm your guy, Halsey Schider, and I am excited to be here talking to you guys today. And honestly, learning something that I really don't have any knowledge about. Joining the show today is Dr. Anita Sengupta, and she's with Hydroplane, and she's essentially the forefront of hydrogen electric propulsion, which just sounds absolutely insane, and applying it in an aviation space, background at NASA, and just a brilliant mind doing some amazing things. So excited to have this conversation today. Before we dive in, of course, big shout out to MHM Publishing and the entire Vertical HeliCASTS platform. We are just so grateful for this relationship that we have with the HeliCASTS platform, and you guys make this possible. And of course, to all of our sponsors, we wouldn't be able to do this without you guys, so we appreciate that support. And my biggest thanks goes, of course, to our listeners. You guys tune in every single week, and that's really what makes this possible. So I'm so grateful for that. Dr. Anita, welcome to the Helicopter Podcast. How are you?
I'm good. Thanks for having me.
Yeah, it's very exciting. I get to chat with some really incredible people. In fact, I think my favorite part of doing the podcast has been I have this opportunity to talk to people that maybe I wouldn't necessarily be connected with if I wasn't doing the podcast and having the platform. And it's kind of this unexpected thing that's happened with the podcast. And so I'm extremely grateful. I've talked to some incredible, very smart people in the past, some folks that come to mind. Hector from Rotor AI, he's doing some really cool things with autonomy and autonomous cockpits. David Smith, actually the CEO of Robinson Helicopters, is a brilliant mind in my opinion, and doing some really cool things. And it seems like you're also a super brilliant mind and doing innovative things within the aviation space. So I'm just lucky to be here. Just tell our listeners a little bit about you, the 2-minute resume, so to speak.
Yeah, sure. So I'm an aerospace engineer. All my degrees are in aerospace engineering, BS, MS, PhD. I spent most of my career, 16 years, working for NASA's Jet Propulsion Laboratory. My PhD is in electric propulsion, but for spacecraft applications. I also have an expertise in entry, descent, and landing systems, which is how to land on the surface of other planets. And I'm also a professor at USC in the Astronautical Engineering Department, and I'm a commercial pilot and a huge aviation and sci-fi enthusiast.
Is that it?
That's it.
My gosh. You don't seem old enough to be able to have that type of resume. That is just absolutely incredible. Where are you right now? You said it's very hot.
Yeah, so we're based in Lancaster, California at Fox Field Airport. So it is in the North Los Angeles desert. We're about, 20 miles away from Edwards Air Force Base out here.
Okay, awesome. Well, there's a lot to unpack there in your resume. I'm going to start with just the reason why, right? I was very lucky. I was born with this itch to fly. So for me, as my earliest memories, I was pretending to fly things. I would build, other kids would build forts. I would build these little airplanes that I would sit in my backyard, and my imagination would take me soaring. And that's really propelled me, no pun intended, to having a full, very awesome career in aviation and being a pilot. For you, obviously, you're a pilot, but you're also an engineer. What drew you to that, and what was really the inspiring factor for you to really pursue that as a career?
So ever since I was a little girl, I was flying on big airplanes. My family is from the UK, and so every summer we would take a Boeing 747, Queen of the Skies, between New York and initially Shannon Airport, and then eventually over to London when you could actually go all the whole distance. So,
Wow.
and my father was also a mechanical engineer, and so I asked him how do airplanes work. He taught me about aerodynamic lift as a small child, but the magic behind sitting on an airplane watching takeoff, always had to have a window seat, kind of made me know that I wanted to be involved in aerospace. And of course, as a science fiction fan, I loved space travel, space exploration. So I chose aerospace engineering as my degree.
Yeah, it's so fascinating. Speaking of lift and the lift equation, producer Zach, who you just met briefly, he has the lift equation tattooed on his bicep area. Uh, so, well, that's incredible to have your dad inspire that and start giving you that knowledge from a young age. I'm fascinated to hear about science fiction too, because I've heard from a lot of people that science fiction, Star Wars, Star Trek, have been actually a motivator for getting into aerospace engineering. Is that like legitimate?
Oh, for sure. And for me, my initial foray, definitely Star Trek. 'Cause I watched it with my dad, but also Doctor Who. And so I used to watch the old school Doctor Who with Tom Baker reruns on local public television. And I was just so fascinated by the ability to travel through time and space, meet alien worlds, alien societies, and the fact that the Doctor, the character, was so intelligent, right? He could basically solve every problem, whether it was mechanical, electrical, or medical. And so I was really kind of inspired by that character to become someone who was also capable of really unique problem solving skills.
Yeah, no, that's absolutely incredible. And speaking of science fiction, I was reading on your homepage there about you and learning more as I'm prepping for the show. And I saw a picture with you and William Shatner. What's that all about?
So during COVID, during the pandemic, I got asked if I wanted to be interviewed by William Shatner, and of course, I'm a huge Star Trek fan, so I was like, oh yes, of course. And so he had a show. It was I forgot the title of the show, but basically he would interview experts, and they would teach him about what they did. And so he wanted to know, how do you land on Mars? And so the episode was about teaching him that.
Oh my goodness, that's so cool. Was it everything that you hoped meeting him?
I mean, he is an amazing person. He, I think, is over 90 or was over 90. He's even older now at the
That's
time.
crazy.
He had, I'd say, more energy than me. So, and people say I have a lot of energy.
I was
So
going to say
so impressed.
you seem pretty spunky, to be honest.
I was so impressed. Yeah, he is a brilliant person. Just kind of understands everything, gets it, can really connect with people. So it was really fascinating to be sitting across the table from somebody who I had only seen in the context of his character for so long, and he was very much like his character.
I mean, that's really neat too. It must have been kind of full circle for you because, you know, legitimately sounds like, Star Trek and other science fiction helped get you to making these decisions of what you're doing now. So it was probably kind of a pinch you moment, I guess, huh?
Yeah, and my PhD research was actually in ion thrusters, and of course the Enterprise had ion drive.
So when you say an ion thruster in the most rudimentary way, what is that?
So, unlike chemical propulsion systems where you're using chemical energy, which is kind of like thermal energy in the reaction between an oxidizer and a fuel, in an electric propulsion system, you're actually generating electricity and you're using that electricity to propel you. So, in the case of an ion thruster, you're creating ions, which are positively charged particles, in this case, positively charged xenon, and then they're accelerated through an electric field and they produce a lot of momentum. So, it isn't a lot of thrust, but it's a lot of efficiency.
What applications would you be using an ion thruster?
For space travel. And so our very first foray into that, well, my very first foray into that was for communication satellites for Boeing. So there's many different communication satellites, orbiting in GEO right now, which use ion thrusters for station keeping and initial orbit raising. And then also the Dawn mission went and visited Vesta and Ceres, which are asteroids and protoplanets. And they could only get there because they were using basically the ion thruster I worked on for my PhD project.
Really?
Yeah, it was cool.
That's absolutely incredible. I want to talk about asteroids, and maybe we'll get to that later. I just have lots of questions. This will be, we'll also, of course, have to talk about helicopters at some point and how this all happens. But I'm just so fascinated. Let's start with NASA. Obviously everyone's very familiar with NASA, And it's almost, to me, I think of like NASA and people that work at NASA as like, just this crazy thing, right? It's just so outside of my normal day to day. I did, in fact, actually have one buddy that worked at NASA, and he was an engineer. He's one of the smartest guys. He's this guy. It drives me nuts, actually. Um, like the other day, he posted on Facebook a picture of his homemade solar panels at his house and all the energy savings. And then, he has a still that he makes his own liquor. He does all this own scuba equipment. I mean, the guy is just an incredible engineer. And he worked at NASA on the crawler, I think it's called. It's like the big platform that takes at that time, I guess, took the shuttle or the other rockets out to the platform. But he's my only other guy that I've ever known at NASA. So how does one get the opportunity to work at NASA? What was that whole process like of interviewing? And, if our listeners are out there and they're pursuing something within engineering or aerospace engineering, or maybe even want to be an astronaut or something like that, what does the process take, and how did you set yourself up to be able to be there?
So I think you have to have a passion, number one, that you really want to be involved in space exploration. I think that comes across for everybody who works there. And then you have to choose what kind of technical track do you want to go on. So you could do aerospace engineering, mechanical engineering, electrical engineering. You could do astrophysics. You could do astronomy. You could do astrobiology. So there's many ways that you can get there on the technical track. And then in terms of getting a job, for me, I ended up graduating with my undergraduate and going to work for Boeing Space and Communications first, just because they came and interviewed at my school, and I did my master's degree whilst working at the same time. And when I was working on my master's degree, one of my professors at USC worked at JPL, and I did really well in his class. It was a propulsion class, and he's like, "Oh, you should come and interview." And so then I interviewed, and then I was able to actually turn my work as a full-time engineer at JPL into my PhD project, which was electric propulsion, ion propulsion. And so that's how I was able to work full time. We're also getting my pilot's license at the same time and get my PhD at the same time. So I think it definitely takes people who have great time management skills and who are really passionate about space exploration.
Yeah, that's incredible. And what were some of the projects that you worked on at NASA?
Oh, my first one was actually operating the Deep Space One mission ion thruster in a vacuum chamber on the ground. And so we ran that test for many years to show how its performance on the ground compared to how its performance in space. You do it in a vacuum chamber, so you're simulating the space environment. So I used a lot of that as my PhD research. My next project was developing much larger, higher voltage, higher thrust ion thrusters for something at the time, which was called the Jupiter Icy Moons Orbiter mission. So we developed the 65 centimeter ion thrusters, huge ones, which could basically power you to a mission to the Jovian system and visit the moons. I did that for about 5 years. Then I shifted over to Mars entry, descent, and landing systems, and I led the development of the supersonic parachute for the Mars Curiosity Rover. And then I did Venus entry, descent, and landing systems to land on the surface of Venus for a mission concept. And then I did a little bit in Earth reentry systems for the crew exploration, or it's currently called Orion. I worked on the drogue parachute for that. And then I did something in the International Space Station atomic physics space. So I kind of moved around quite a bit during the course of my 16 years there.
How does, I think Zach said this pretty well before you got on. We were kind of chatting about, your background and just the extensiveness. And, I think what he was trying to ask, or his point, was this idea of like, how do you even begin to problem solve something that's like so almost seems so unobtainable? Like, for instance, a parachute system that's deploying, above Mars, so a rover can land successfully. Where do you even start with that? And how much time and research goes in before that like final product actually happens?
Well, with most things in the space program and most things in technology, you're not reinventing the wheel from scratch, right? You're doing an incremental improvement. So you can do background research and see what's been done before, and then use that to make the solution better fit to your specific set of requirements. So I certainly did a lot of background research on the systems that were developed for, it was called the Viking program for the Viking landers many decades before. But of course, things happen. As you go through time, you actually get improvements in materials, so things become lighter weight. You have better techniques using, computational tools to do design. So you can actually take advantage of all the work that was done before and then use modern tools and modern materials to have a better design going forward. So that's kind of what I did. But as a research technology technologists, you're trained to solve problems like this. That's one of the reasons why there is advantage in getting a PhD if you want to develop technology, because you actually know how to solve complicated technology problems and make improvements as new things come into the pipeline, like materials and computational techniques.
And here's a really stupid question, but how long does it take to get to Mars?
It depends on your trajectory, but usually between 7 to 9 months. So basically the gestation period for a human being. I always joke, this gestation period between like a sloth and a human being.
That's funny. I guess for you, how much time was put into being able to create am I saying it right, a parachute that essentially helps arrest and get the descent into Mars? Like how long did you work on that specific project? And what was that moment like when it deployed and it worked and it was successful?
At Astronautics, we're aviation problem solvers. With over 60 years of OEM and retrofit experience, bring us your toughest avionics, connectivity, cybersecurity, and system challenges. We'll work with you to find an innovative, reliable, and quality solution. We turn problems into solutions. Visit us at astronautics.com.
I worked on that for about 4 years, and you have to go through a series of design gates. So you start off with a conceptual design where you figure out, well, how much do I need to slow down, and what are my requirements in terms of my opening conditions, and what speed do I want to be at when I'm finished on the parachute descent. And then you can go through and size that. Then you would go through and work with a vendor who would actually manufacture it for you based off of your requirements. And then you design a test program and an analysis program to make sure that it gives you the performance that you're looking for and also will survive the environment. So it's a kind of a multi-step process that you have to go through. But once again, you're not reinventing the wheel because it's been done in some other capacity before, so you could leverage that. But what was so interesting about it was that it was the largest parachute that had ever been built for supersonic applications to date. And we were given a very special challenge, which was that you're not going to be able to test this thing at full scale ahead of time in those conditions. You have to come up with another way to show that it's going to survive. So I spent about 2.5 years developing a test program where we made subscale versions of the parachute and tested them in a wind tunnel, a supersonic wind tunnel at NASA Glenn, to show that they would give us the aerodynamic performance. And then we also developed very sophisticated computational tools to show that analytically what the performance was going to be like in this very unusual, dynamic, unstable aerodynamic environment. But yeah, it's very much a research project, but it was necessary to be able to show that it would work the first time because you only have one parachute. So if that parachute fails, the rover goes crashing to the ground, mission over.
Oof, that's a lot of pressure.
It was interesting, though. So I think it was an interesting technical challenge. And so most people who work on this stuff, they do it because they really like the technical challenge. So I don't think you ever think like, oh, what if it doesn't work? You're always thinking about how am I going to make it work, right?
Yeah,
so,
of course.
Yeah, definitely more of an optimistic mindset to work on these projects. Otherwise, you might get overwhelmed.
Yeah, no, I can certainly see that for sure. What is, at your time at NASA, something that you consider like your proudest or your biggest achievement?
Well, I mean, I liked all of my projects. So every single one sort of culminated in a mission and a launch. So each one is wonderful in that regard. But I think landing something on another planet, it's hard to top that. So I think that for me probably was the most amazing thing, being there on landing night and getting all the telemetry coming in and right after basically touchdown. So it goes off of the parachute onto a series of retro rockets, but after it touches down after the sky crane, it actually sends a picture back saying that it's okay. And then we were also able to get one of the orbiting assets to take a photograph of the rover under descent under the parachute, and that also was sent back to our mobile phones that night. So it was
gosh.
Nice. It was fantastic.
Yeah, that's
really puts it in perspective.
Yeah, I mean, it's just it's out of this world, truly incredible. And you were talking about asteroids earlier. What do I need to be concerned? Any asteroids approaching Earth anytime soon?
Well, these are ones which are in the main asteroid belt, so those are explored for other reasons to understand. So asteroids basically represent the building blocks of our solar system, but they're a lot smaller. So if you can interrogate the asteroid in terms of what it's made of, you get a better understanding of basically how all of the different planets in our solar system were formed. And in the main asteroid belt specifically, a lot of those are believed to be the building blocks of the planets that we have in our solar system. So they're just difficult to get to because they're far away, and then they're really small. So you have to be able to slow down to be able to put yourself in orbit around one or even land on one.
And when you say like
nothing right now.
That's good. When you say like they're really small, how small are they, or really how big are they?
I mean, they can be, tens of kilometers to hundreds of kilometers in size. I mean, there's probably smaller ones, but maybe they're not called an asteroid at that point. But the ones that we went to for the Dawn mission was Vesta was an asteroid, and then Ceres was actually a protoplanet. So that's considered a very big asteroid, and it's starting to maybe undergo, gravitational differentiation, sort of how a planet would form. So you get all kinds of really interesting scientific information by visiting these celestial bodies.
And how long does it take to get to the asteroid belt?
Well, that one, I think it took several years because of the trajectory, but it depends upon what your trajectory is. So for a electric propulsion system, you basically are constantly going around and around and around, increasing the size of your orbit. So it's not like a direct transfer, but it's a very efficient way to do it, because ultimately with the chemical system, you probably just couldn't ever get you enough fuel, carry enough fuel to be able to get there. So this is a way to get there. And you're constantly accelerating, so you're going faster and faster as you get there.
Man, it's wild. It is crazy that people like you exist to do all these crazy things. It blows my mind. Again, I think of space. It's like so off my radar, and the fact that there's just amazing people out there doing this type of work, this research, to go and explore space, to land on other planets, to investigate asteroids. Man, it just gives me that's like what I love about humanity. I think it's incredible, just the ingenuity that we have, and I'm just thankful. I kind of joke about that in the past when I'm like flying a helicopter. I'm in this machine that I honestly fully don't understand, to be frank, right? I'm a pilot. I have a high school diploma, and then I went and learned how to fly helicopters. And I always get this crazy sense of like, I can't believe humans figured this out, and that's a helicopter, let alone landing a vehicle on Mars. So it's just, it's so neat. It gives me it makes me excited for humanity. And I think oftentimes people think about, all the bad that can happen in this world, or all the craziness, especially right now, and the polarization. But at the end of the day, man, humans are cool. Man, we're doing some incredible things, and the research that you're doing is really special. I want to talk about your flying experience. Obviously, that seems like it's important to you. Was it always this thing of like, I'm going to learn how to fly, or is it just kind of naturally happen through the progression of your career in aerospace engineering?
Well, I always wanted to fly, just because of my experience flying every single summer. And then actually one of the reasons why I took that job at Boeing right out of school is because they're like, we'll pay for your master's degree and your pilot's license. I'm like, okay, I'm sold.
Cool.
I don't know if they still do it anymore, but back then they gave you money for when you soloed and the money when you finished your certificate. So I was like, okay, let's do it. And so then I started flying many years ago out of John Wayne Airport, which is a very big airport in Southern California. So my experience was always, like the smaller runway for the little airplanes, and then Southwest off the side, right? So caution wake turbulence was always there for me because we were at a pretty big airport. And then I did that. I got my license, and then I bought a house, and I couldn't really afford to pay my mortgage and keep flying. So I had to take a bit of a hiatus, but then I picked it back up again about, I think, several years later, and I got my instrument rating. This time I was flying with the Caltech Flying Club because I was working at JPL. And then maybe 2 years after that, during COVID, I decided to get my commercial license and did that too. And as I now have a aviation company, it just made a lot of sense for me to keep on gaining ratings, keep on gaining expertise. And ultimately what I'd like to do next is get a helicopter the license. And I believe since I already have a commercial, you could transfer the commercial over to the helicopter.
Yeah.
So if we do win our next project for the larger helicopter activity, then I probably will go do that.
Yeah, totally. It would make sense, right? To be able to fully immerse yourself in helicopters. And, I think it would actually help you in your research, of course.
Absolutely.
And you're right. I think, I can't speak to exactly the way you would skin it, but Part 61 training is going to have aeronautical experience requirements that you have to hit. And I'm guessing that there is a portion of those hours that are fixed wing that can go towards your helicopter. And so I think that would be pretty neat as well. I mean, you're in California, you're very close to the Robinson, helicopter company factory. It's a great training platform. And actually recently we sold a helicopter. That's my main business, is selling aircraft, used helicopters and airplanes. And we sold an R-66 that I think maybe being retrofitted for some type of new propulsion. So I do know that the
Oh,
Robinson platform itself is being used by companies to explore new forms of propulsion, which leads us into your company, Hydroplane. What is Hydroplane, and what are some of the recent successes, and what is the future look like for aviation if you have your way?
so Hydroplane is my small business. It's a startup. I started it during the pandemic. Ironically, I had left NASA, gone to work for another crazy startup, Virgin Hyperloop, which is that's a whole nother interesting conversation in of itself. But I learned a lot about business development, how to run an organization, because I was an executive there, and how to raise capital. And so during COVID, I'm like, you know what? Now it's time for me to start my own company. And what I really wanted to do, since I had worked for a green transportation company, which was the Hyperloop, was I wanted to create my own green transportation company. So I figured my love of general aviation and wanting to do my part to take my engineering skills to solve decarbonization of the most difficult thing to decarbonize, which is aircraft. I did a little bit of background research on how to get funding from the government. So I watched a bunch of webinars and I found out that the Air Force was interested in alternative propulsion systems that would be electrification, right? Whether it would be with a battery or with a fuel cell, to have range extension. And it was pretty clear that the only solution for range extension for electrification was hydrogen fuel cell based electrification. So I was able to get seed funding from the company by submitting a proposal to the Agility Prime program. We won a phase one. Then I was able to raise private capital with angel investment. And then we submitted our next proposal to the Air Force. We won the phase two, and we were able to fund our first development, which was a system for single engine aircraft. And then since then, we've won several other government contracts as well, because I am a research technologist. So I'm do a good job at writing technical proposals and implementing and executing on them.
Yeah, one thing is, business ownership is interesting because you start a business because you're passionate about something, or that's why you should start a business. So clearly, those boxes are checked. You're passionate about alternative fuel sources for aviation, and you also, of course, have the background and the knowledge and the experience. Similar to me starting my business, which I also started right before COVID. It was like weeks before. I quit all my jobs. At that time, I was flying full-time air medical. I was also selling roofs, which is crazy, but I was making a lot of money doing that. And then I decided to go full scale into my aircraft sales business, and then boom, COVID hit. That's a different story for maybe a different podcast, but crazy time to start a business, by the way. So good on you for still being here. But one thing that I found in my business personally is that there's so much to business that isn't necessarily about the business that you're doing. So in my case, I was passionate about sales. I love sales. And I was really knowledgeable about helicopters. So I figured, okay, I could put those two together. But I didn't really understand business development. I didn't understand accounting, all these other taxes, right? And how to file, how should I be an S Corp? How do I do this? All these things, right? That are so different from actually the vision of what you're doing in business. How have you navigated that?
That was really hard. I had a few friends in my network who were entrepreneurs, and so they connected me to somebody to help me with the incorporation. They also connected me to their corporate attorney, and that corporate attorney helped me a lot in terms of like the right way to set up the corporation and the way to do fundraising. So I was able to leverage that expertise, so I didn't have to go it alone. But it definitely has been a learning process. And for me, same thing. Accounting. I hired my friend's bookkeeper. I hired my friend's CPA. Right. So I was able to utilize my network to connect me to these people who are experts. And one of the things people have always asked me, oh, how can you do these really difficult things, like for things that are engineering? It's like, well, you learn from people who already know how to do it. So for me, I was immediately going out and looking for people in my network who could help me, who could do this, who've done this before, who would advise me. And then I'll do more background research and learn on my own. But I certainly don't enjoy those aspects in terms of all of the paperwork. It's awful.
Yeah.
And the day that I can hire more people to do all of that for me is the best.
Yeah. And I mean, more people, more problems, though. So it's always right. The business is growth, right? There's always kind of, it's maybe similar. I just had a baby. It's my first baby. And what I'm noticing about having a baby is that when you think you have it figured out, then it completely changes. So you think you got the sleeping routine figured out, and then no, you don't actually. You think you got the feeding routine down. Nope, you don't. It just changes. And that's similar to my business experience of like, you get to these milestones and it's exciting. You celebrate that. You think you kind of know it all. And then something comes up and you're like, God damn, it's just this constant learning. But that's what I love about business. I think that as an adult, I was a big, I was really into sports, growing up. I played competitive sports. I'm still an avid skier. I'm a very competitive person, but I'm 37 now. My body's kind of beat up a little bit from my football days and skiing accidents and whatnot. I can't really compete in sports anymore, right? It's just not possible. Maybe I could, but I don't think I can. And so for me, entrepreneurship and business is that competition, right? It's that way to go out there and work hard and see results, be competitive. It's just really, really fun. And so I love entrepreneurialism, but it's often lonely. I find myself being a little bit isolated because all of my friends don't do that, right? A lot of them are 9 to 5. Has there been moments of this journey for you that have felt a little bit lonely as an entrepreneur?
Thank you to our sponsor, Precision Aviation Group. Mission-critical operators and fleet managers rely on Precision Aviation Group as a worldwide leading rotor and fixed-wing MRO provider. PAG provides tip-to-tail solutions in 4 MRO segments: avionics, components, engines, and manufacturing DER services. A single point of contact gives you access to over 150 million in inventory globally, 24/7. Just call 800-537-2778. Precision Aviation Group. Others sell parts. We sell support.
For sure. And then I do have a few friends in the space, so I do oftentimes reach out to them and we talk and we vent about how difficult things are. But I think probably the biggest challenge for, being a small business and a startup, which is very capital intensive, just like your industry, is money, is fundraising. So I think that's probably the biggest stress, the biggest challenge is making sure that we, can go to live another day and win another contract, raise more capital. So I think that's always been the part that I find the most stressful because I'm a very conservative person when it comes to like my personal finances, and I treat my company the same way. So it's like I want to make sure we're always healthy and solvent and are in a good position moving forward. And so as a result, I'm constantly writing proposals so that we can win more revenue, right? Basically non-dilutive funding from the government, which keeps me on my toes and ultimately allows us to develop amazing new technology because the government really only funds really interesting research in that perspective. So it's a good forcing function for me to constantly innovate.
Yeah, it's incredible. And it's obviously you're the right person. You have the right background. So I'm guessing when you're going out and fundraising and talking to different folks, whether they're public or government, for funding, I'm guessing you definitely can talk the language to give people the confidence to write the checks essentially. And, it's so important. I think that I'm guessing what you're doing is essentially kind of the next generation of what we're going to see in aviation. So someone like me that has no idea about propulsion, I literally have no idea. I mean, look, I can kind of tell you how the piston engine works. I can kind of tell you how a turbine engine works. So in the most rudimentary way, if you could explain to me exactly what your company does and how it is applied to aviation and what you guys recently did with the Army regarding helicopters.
Awesome. Yeah. So we are developing hydrogen fuel cell based power plants for electric propulsion and also for power generation. And so at the heart of the system is a hydrogen fuel cell. Hydrogen fuel cell was actually originally developed by NASA for the space program. You can think of it as a hydrogen ion battery, for lack of a better term. But the way it works is you have a series of metal plates. Those metal plates have channels that are etched or stamped into them, and either hydrogen flows through the channel or air or oxygen flows to the other side. And in between the plates is something called a polymer exchange membrane. That polymer exchange membrane basically kind of forces hydrogen ions to flow through it. And on the other side, those hydrogen ions then combine with oxygen ions from the air. And when you create a hydrogen ion, which is created from hydrogen gas, which is basically your source of fuel, you release an electron. those electrons are the source of electricity. So for each hydrogen gas molecule that you dissociate and you release electrons from it, you have electricity, which is your battery. And then on the other side, where the reaction is completed, is called the oxidation reduction reaction. Those hydrogen ions pass through that membrane, which kind of looks like a piece of saran wrap, for lack of a better term, and then combine with oxygen from the air, and they produce their waste product, which is liquid water. So it's incredibly clean, incredibly efficient. There's no moving parts. It's low temperature. It's essentially low pressure. So it can last for an incredibly long time, far more so than batteries and even more so than combustion systems because of that environment. And you're producing a lot of electricity, high power density, high energy density. So it's one of the lightest weight ways to electrify a system. So once you produce that electricity, you then sometimes will have to change the voltage of it with a DC to DC converter. And then you'll oftentimes have to invert it from DC direct current to AC alternating current. And then that then powers your electric motor. There are many different electric motors that exist out there. We use an axial flux electric motor. The electric motor is then coupled to a propeller. It spins, and then you get your lift via the propeller, or to a rotor transmission system that spins, and then you get your lift.
So, I mean, from that rudimentary explanation, and thank you, by the way, I think I get it, kind of. I got to be honest, it's very limited still. But so I'm going to ask
complex.
I'm going to ask some stupid questions, I'm sure. But I mean, it sounds like it's an amazing thing. Why has it not been such a forefront of, I think of like a car or something? Like why is hydrogen fuel cells not something that's used all the time?
So I drive a hydrogen fuel cell car. There's actually 3 on the market that you can buy. They're only for sale in California because California as a state made an investment in hydrogen infrastructure so that there are fueling stations that you can go to, which are part of the regular fueling station where you can go and put hydrogen into your vehicle. So a lot of it's more of a chicken and the egg problem, which is that, well, you got to put in the fueling station. You got to put in the charging station in order to shift to this new technology. It's almost never a technology limitation on the propulsion side. The same would go with batteries, right? So battery technologies existed forever. Yes, lithium-ion batteries are much better, but you could still go with an even older school lead-acid battery, and you could have had a battery car. But there's a lot of inertia in industries which are really large that don't necessarily innovate because they would be perhaps innovating themselves out of existence. And I would say aerospace, transportation is also a lot of inertia. It takes a long time to be able to shift people over to new technologies, and it takes disruptors to the market, right? It doesn't take the regular mainstream companies. They never will do it, right? That's the reason why Tesla was so successful, right? Somebody came in from the outside, not part of that business, revolutionized it, not because the technology was new, just because nobody was doing it. And the same applies for hydrogen fuel cell technology. It's been around for decades. It's been used in the space program, right? So if you can do it in space, you can do it here on Earth, which is an air breathing system here on Earth. It takes the right person. It takes the people with the courage to change, and it takes investors and municipalities to make those investments in the future. But what you get is an elegant, efficient, clean, scalable solution to power generation and to electric propulsion, which blows away combustion and blows away batteries at the same time. So in my opinion, it's the right solution.
So some more stupid questions coming at you hot here. So let me just make sure that I'm understanding it right. Essentially, it's not the hydrogen cell that's providing the propulsion, it's providing the electricity to then run the electric motors.
Yes, okay. The fuel cell, basically each cell in a fuel cell stack produces roughly a volt. So if you want 10 volts, you have 10 cells. You want 300 volts, you have 300 cells. The area of the cell tells you what your current is. And so power is equal to voltage times current. So you want higher voltage, you can have higher power with high voltage, you can have higher power with higher current. But so it's inherently a modular system because you add more plates or you have bigger plates and you get to higher powers. So it is such an elegant system. And then it produces that electricity. So at whatever voltage and current that you've selected, which then is DC voltage, which then you can convert to AC if you need to, or you can keep it as DC if you have a DC power need, for example. So as a company, we actually make both propulsion systems for aircraft and helicopters, but we also make ground power units, like to replace the diesel generator in your hangar for a GPU.
Sure. So like to power, say, a small airplane, how big of a unit are we talking about as a hydrogen fuel cell?
So our goal for our power plant was to give you a drop-in replacement for your Lycoming or your Continental or your Rotax. So our system is a little bit bulkier because it's not an engine, right? It's a box with other boxes associated with it. But from a mass perspective, if you store liquid hydrogen if you store hydrogen in liquid form, we can give you the same payload and the same range, but actually even better range. So one of the things that we're doing for the Army with the helicopter use case is that with liquid hydrogen, we can give you better range, which is pretty important, from a mission
of course.
profile perspective.
And when you talk about your car, look, I must be out of it because I had no idea that we have cars that have a hydrogen fuel cell. Uh, what? How often are you having to put hydrogen in the fuel cell? And like, I guess from a car perspective, which might be a little bit easier for me and my listeners to comprehend, like, what kind of advantages do you have with having, say, a hydrogen fuel cell that's powering your battery or your motor compared to, say, like your just standard Tesla or electric vehicle?
So when you're using hydrogen, you're having a fuel which has 3 times the specific energy, so energy per unit mass, as compared to hydrocarbons, and probably 10 times the specific energy per unit mass as compared to lithium-ion batteries. So the system is inherently lighter weight. And then the fuel itself, because it weighs less, you can basically carry more of it and go a longer distance. And then when you use the hydrogen in an electrochemical way, which is in a fuel cell, it's much more efficient than combusting it. So when you see a diesel engine efficiency maybe as low as 20%, with fuel cells, you can have efficiency well above 50%, well above 60%, depending upon where you are on the power curve. So in order to implement the same amount of stored energy, you're needing a lot less fuel. So ultimately, it can save you money. Obviously, there's the emissions aspect of it, right? Because you're no longer, putting out CO2 or any NOx or SOx, right? And then from a noise perspective, it's really quiet. And because it's essentially low temperature, low pressure, it's very durable. There's no moving parts. Your maintenance basically goes to almost zero. So just like if you have a battery electric car, very little maintenance costs. If you have a fuel cell car, very little maintenance costs.
And what about like the safety of hydrogen compared to, say, what we've been using in just like normal Jet A or 100 low lead for fuel?
So I love answering that question because there's so many great answers to that question. So the DOE, the Department of Energy, has done a lot of studies looking at hydrogen fuel cell cars and gasoline cars. And there's this great graphic where there was a leak in the hydrogen car that was ignited, and it creates because the hydrogen gas is so lightweight, it just diffuses into the atmosphere. So it created a little column of flame at the end of the fire. The car was there unchanged. They did the same thing with a regular gasoline power car. At the end of the fire, it was burned to a crisp. So because the gas itself is able to diffuse so rapidly and it has lower radiant heat to the surrounding environment, you actually have less of a fire risk. And from an aviation perspective, if you could choose to venture fuel overboard ahead of time so that if you did have an engine out scenario, when you landed, you'd have a hard landing, but you'd have absolutely no explosion.
No
right?
fuel.
So you can actually be a lot safer as a result. And the way the fuel cell system works is that the fuel is stored in a tank. It's not stored inside the fuel cell. You just release a small amount of it into the fuel cell during operation. So if you did have any kind of leak anywhere and you have leak detectors in the system, you simply close the valve and you stop flowing. And then the amount of hydrogen that's left in the system immediately dissipates because it's a super lightweight molecule. And then unlike gasoline and unlike diesel, when you have vapors, because they're heavy, they pool, they stay at the ground. With hydrogen, it rapidly dissipates into the atmosphere. So in most ways, your safety is improved as a result of that from a combustibility perspective.
And what about reliability? So one of the things, like when you're learning how to fly airplanes, for me, when I'm learning how to fly helicopters, which I hope that you get to experience sooner than later, is we're always practicing for an engine failure. Lots of auto rotations. I know that in airplanes, you're doing power off 180s and all these other maneuvers to practice for this engine failure. And honestly, the turbine, standard turbine engine, a piston engine, I mean, they're fairly reliable, right? For the most part. Knock on wood, I've never had any type of engine issue in my flight hours. I've had a couple friends that have had legitimate, full engine shutdowns. But we're always training for it, which I'm guessing is important. It's a big event. How much more reliable is hydrogen power over just your standard combustion engine?
So I'd say there's a lot more pieces and components and subsystems in an electric propulsion system, right? Because you've got your electric motor, you've got your power electronics, you've got your electricity source, which in our case is a fuel cell, and a battery, it's a battery. And you've got, switches in between, you've got let's see what other components. In our case, we're liquid cooled, so we have a liquid cooling system. So there are more components, which means that there are places where you might want to have more redundancy to mitigate if one of those components failed, for example. But inherently, the fuel cell, when you put it into a vehicle, whether it's a ground vehicle or an aircraft vehicle, it's there for the life of the vehicle. They're designed to last for decades. So in that sense, the fuel cell itself, if you treat it properly, which is that you give it clean gases, in the case of hydrogen, obviously is the clean one that you select to go into your tank, it can last for longer than a combustion system. And all of the failure modes that you get with high temperature and high pressure operation are essentially gone. So All the other units are line replaceable units. So if you had some kind of, switch that failed or a breaker popped, you could always replace that relatively easily. But from a design perspective for aviation, you have to design the system to the requirements for reliability per the FAA. So the system would have to meet that anyway. There are aspects of fuel cells where you can have, in our helicopter solution, for example, we have 2 stacks. So you have redundancy with the stack. So if one was having a problem, you do have the second one. And then from an electric motor perspective, you can have multiple windings. You can have redundancy also built into your electric motor. So it's a very different way of applying redundancy and applying, system level reliability with an electric propulsion system, but you can absolutely achieve it. And I would argue you could probably do much better than combustion. And it's so amenable to predictive maintenance. So that's the other thing that we recently proposed to the Air Force, which is we inherently have a digital twin in our system, which is our digital throttle. And we can use that digital twin to monitor everything so you can have a better understanding of, is there a part which is having an issue that needs to be replaced or serviced sooner rather than it actually failing.
And talk to us what you guys recently accomplished with your helicopter testing with the Army.
Yeah, so what we did was we applied to the Army X-Tech 8 program, which is a competition, and we won. So there are a few winners, but obviously it's very highly selective. I think there's hundreds and hundreds of companies and got down to just a few. And then after you win it, then you get to apply for a contract. And so we won the contract, which was our phase 1. And so for that phase 1, what we said we were going to do for them was a full-scale hydrogen fuel cell powered rotor. At full scale, in this case, we purchased a 23-foot gyrocopter rotor, and we spun it to flight speeds, which in the case of this gyrocopter was 345 RPM. And so we basically purchased the blades because they were a very cost-effective way to get a very large set of blades. We attached it to our propulsion system. We made a custom transmission to take the RPM directly off of the shaft of the electric motor through, I think, a 3-to-1 ratio to basically spin the rotor to the correct RPM because we had to match the torque that it needed. And we demonstrated that it worked. And what's so amazing about it is that because the system is so efficient, it actually requires less power to get to that flight speed than you would need for a combustion type system. And it's really, really quiet. So until it really gets up to flight speed, you hear nothing. So, think of that from a noise pollution perspective. Think of that from a stealth perspective, right? If you're trying to get away quickly from a mission. So and once again, too, because of the lightweight nature of hydrogen, if you store it as a liquid, you can get better range, right? So from a helicopter mission profile, having more range, more endurance is fantastic.
Yeah, and I would almost kind of wonder as well from a safety aspect of if the hydrogen fuel cell is having an issue, would there be like a backup battery maybe that could give you a little more juice to, plan a safe landing or something like that?
Thank you to our sponsor, Robinson Helicopter Company, the choice for unrivaled safety and reliability so you can accomplish any mission with confidence. For more than half a century, Robinson has been at the forefront of the helicopter industry. From the R-22 to the R-66 turbine, Robinson makes helicopters accessible so more people can accomplish more missions. Climb higher. For additional information, visit www.robinsonheli.com.
So we do have a start battery. So it's up to us in the architecture whether or not we have the start battery, be it low voltage going through a DC-DC converter or being high voltage. I particularly don't like lithium-ion batteries because they're quite unsafe. So if a lithium-ion battery catches fire, it doesn't go out until it's done burning. So it presents a huge risk, in my opinion, to people on an airplane. So my goal is to have as small a possible lithium-ion battery only used to start the system, for example. But ultimately, for a helicopter, you don't have to design in features that you would normally have, right? So you don't have to have a second engine for a smaller helicopter. Same thing for a single engine aircraft. Your altitude margin is your redundancy in that sense. But because we have 2 fuel cells, which can be on independent buses from each other, for example, you can have redundancy there. But we have to make the decision of what's the right solution based off of likelihood of failures and system level reliability, and also, weight margin, right? Because you end up flying a tank, you'll never get off the ground either. But there's nothing inherently about the system which it has the ability to actually have a lot more safety features than a traditional combustion system.
Well, congratulations on winning the contract, winning the competition. Obviously, that means you're doing something right. So there's validation just in that, which is super cool. From winning the contract to actually then displaying an MVP, call it, how long was that process? And how big is your team that is helping you put this all together?
So it was a really rapid effort. So we were able to do it in under 6 months, which is kind of shocking. But we operate pretty efficiently, and we had just done it for our aircraft application. So we were able to leverage that experience base onto this different platform. But doing the transmission was different, for example. So that was something which was fun for us to do. And hopefully we get to do it even further with higher power levels. The team is quite small. So we're 12 people, but really high efficiency. A lot of us come from the space program, and all of us are hands-on engineers. So we just everybody wears multiple hats, and everybody does everything, and that's kind of the way you have to be as a startup. And everyone's very passionate about our mission.
And what is the day in the life of for you?
For me, it's driving from where I live in Los Angeles up the 14 freeway to our hangar in Lancaster. And then in the morning, we usually do some meetings, work on some design activities. And then in the afternoon, we do our testing. And so right now, we've been making modifications to our power distribution electronics boxes and adding in some filtering so that we could get rid of a little bit of noise that we're seeing on one of our AC devices. Then we've just run tests to be able to have more optimum efficiency. We're developing our flight software as well. So I mentioned before that we have a digital twin. So we're building in more capabilities to make the system even more automated. So hopefully that will couple to maybe an autonomous drone flight sometime in the near future. It's something we're also interested in. But now, because it's so hot, we're starting a little bit earlier. So we're starting our testing earlier, finishing it earlier, and then doing more engineering design work in the afternoon. But yeah, that's it. It's every day it's in the hangar and working on hardware and building up different electrical assemblies and then testing them.
You talked about change being difficult and being a disruptor being difficult. Has there been pushback within the space of don't do this, or you're causing a problem, or is it that overt, like people will say things, or is it more just maybe other forms of, say, sabotage or getting in the way to try to stop your progress?
I would say we haven't experienced any negativity from the industry as a whole. I think the larger entities are always watching and wanting to see, how the smaller companies are doing, and maybe they'll make some kind of direct investment, or maybe they'll even make an acquisition at some point, like Boeing purchased Aurora Flight Sciences, for example, I think because of their autonomy capabilities. So I would say nothing negative. I think it helps us to understand what their apprehension is towards adopting new technology, because then we can make sure that we meet whatever performance metrics that they need, like, for example, to get this thing into a much larger aircraft. But we learn from them in terms of making sure we have a good business argument behind why we should do things our way. I would say probably the larger challenge is being able to get private capital to invest in these new technologies. So that apprehension is probably more on the private capital side than it is on the aviation side. So I think that's unfortunate, because with private capital, I would much rather see private capital put towards decarbonizing aviation and maritime and heavy duty trucking than the next AI tool, right? So I think that's my biggest sadness when I look at the business space, is how I think money is spent on things which really don't advance society in an important way, and they should be spent on advancing society and something which improves air quality, human health, connectivity, and opportunity across the globe. So that's what I'd like to see change, is more private capital put towards green energy and green transportation initiatives.
Man, I feel like someone listens to this podcast and they got some money they would invest. We
have a round that's going to open up really soon. So yeah, certainly send me a message.
Yeah, perfect. Yeah, that's it's very interesting. It seems like it's the next iteration. Just in what you're telling me, it's a reliable, safe, efficient way with water as its emission, which is just crazy to me.
Seems like a no-brainer. I agree. The only reason it is a lot more difficult, right? So from an engineering perspective, the complexity is far much more complexity as compared to combustion, as well as compared to battery systems. Like battery, everybody went the battery route because it was easy to do, but it wasn't a good solution because it's so heavy. So this is more complicated, but it can be done if you have the right people working on it, and then you get a much better result.
Is it drastically more expensive right now because of that complexity?
No, it's more complexity adds to a more difficult engineering process, right? So you need more skills to be able to implement it. From a cost perspective, the cars that are on the market are the same price as any other battery-powered car or combustion-powered car. So the price differential isn't there. And ultimately, the cost of ownership has the potential to go way down for the aviation use case and for the operator use case because of the reduced maintenance. But unit cost, no, it isn't any much more expensive. Like, we're looking to target for smaller platforms, right? We just had this change recently with the Mosaic ruling from the FAA. So now we can also look at making a system for light sport aircraft. So we then obviously have to be very cost competitive at that price point. So, but we think we can do it because we actually made our own fuel cell. So we know how to reduce the cost. We know how to reduce the system weight across the board, from component all the way to system level. And that's the way you really optimize the system, is understanding it.
Yeah, very, very fascinating. Now, are you collaborating with anyone else within your space or kind of parallel space, say in the eVTOL world?
So we have lots of, partnerships and support, letters of support and letters of interest from big players as well as small players. We have a complete supply chain of people for a lot of our component hardware. So we've got a great team that we're working together. A lot of that I can't release just because it's, confidential. But no, we're happy with the level of support that we've gotten so far. And I think as we move forward with this next set of proposal opportunities, if we win them, we'll actually be able to drastically improve even our specific power, which then all of a sudden makes us a very attractive option for larger aircraft.
Yeah, it's very cool. So as we wind down here a little bit, just some fun questions. When you're not solving this problem of decarbonizing aviation, I'm guessing there's not too much time in the day, but what do you like to do that's outside of your profession just for fun?
Oh, I'm a big biker. So I like to mountain bike and then also bike by the beach because I live in Southern California. And I also like to hike. So because I spend my entire week inside of an aircraft hangar, I usually like to spend my weekend in some kind of beautiful natural environment. So yeah, I'm a big outdoor enthusiast.
Well, Southern California is gorgeous for that. Of course, I have family down there. My wife's family grew up in the LA area, so we go down there every once in a while. I'm not too far away. I'm just north here and up in Oregon. Super beautiful as well. And yeah, great.
I love Portland.
Yeah, great recreation. Yeah, I'm from Portland. Now I live just outside of Bend, which is, I'm biased, but it's maybe one of the most incredible places where you can live especially if you're an outdoor enthusiast, skiing, mountain biking, hiking, rafting, you name it. It's just absolutely incredible. Interesting. I always try to kind of hit on this. I don't try to make it a big thing because I don't think it needs to be a big thing, but I think it should be recognized that within aviation, and I'm guessing within the subset of aeronautical engineering, women and females are probably highly outnumbered by male counterparts. I know that to be true in aviation, specific helicopter aviation. It's even more of a drastic barrier between, men and women in the workforce. And I think it's really neat. I think my podcast, we've been able to have some really badass women, including yourself, on the show, inspiring, and I think maybe providing this path, right? And maybe that's a big difference in our society now is there's YouTube and Instagram and all these places where they can be negative, but also a positive is like you can inspire people that maybe felt like it wasn't possible for, say, a woman to, have this crazy, amazing career at NASA. So what are you doing to help inspire the next generation of young females that want to get into engineering?
So I do a lot of science communication. So when I had more free time, I actually did a lot of speaking engagements like around the world. So now I prefer to stick to it with podcasts because it's easier for me so I can work. I'm also a professor, so I obviously mentor a lot of students, and I'm an executive mentor in several different fellowship programs, which sometimes focus on women, sometimes they don't, but they usually assign women students to me. But yeah, I think I just like to get myself out there in terms of social media. So I think social media is a tool, and if you use it for education, if you use it for public relations, if you use it for networking, it can be very positive. And I think this is one of the ways, obviously doing your podcast is a way to kind of share that story with other people. And I think I had very different perspective because my father was an engineer, so I never really felt like it was something that I couldn't do and he always encouraged me to learn with him on how to fix the car and how to fix electrical outlets in the house, right? So for me, I never had that societal hang up that said I couldn't do it. For me, it was always normal. And I have a lot of friends like me too who became engineers. They had the same situation, so they never had that hang up. So it's because when people don't get that exposure when they're young and they're only exposed to media where they can portray women in horrible ways, right? Like being sex objects or whatever, which I think that kind of tends to make people feel like they're not capable or don't have the confidence. And I think everybody does struggle with confidence during the course of their career. So that's something you always have to kind of get past. And aviation helps a lot with that, actually, because it puts you in a really difficult zone where you gotta survive and make it work. So I think challenging yourself in that way is important. But yeah, I would like to see more women in aerospace, whether that's on the space side or the aviation side. And I'd like to see more women pilots. And it's the thing is, it's such a fun career. It's such a fun industry to work in. You're just totally missing out if you don't do it. So
Yeah,
it's
totally.
like, it's fun. So do it.
Yeah, absolutely. And like you said, I think it's important to be able to, I think just by being present, and doing speaking events and coming on my podcast or doing other things. I mean, that just, I'm guessing you've had tremendous impact on a lot of people making decisions, men and women, right? Which is pretty cool. I have a little brand new daughter, and so I'm excited to see how she develops and what she is inspired to do. And I hope that I can, I don't even. Part of me is like, I don't know if I want her in aviation, but I'm excited to see what she wants to do, and then hopefully be able to support her in that journey. I think that's what it's about, being a parent, and hopefully enable her to feel like she can do anything, because truly any of us can do anything, which is so cool. It's truly the American dream. You can be a super smart aeronautical engineer, work for NASA, probably have a lot of security, and then have this crazy idea of starting your own company. I mean, tell me that isn't the American dream. I absolutely love it. What a conversation. I got to be honest, I was nervous coming into it. I feel like when it comes to intellect, my intellect's different. I have like a street smart, maybe even not. I don't know if I'd be that great on the streets, to be honest. But in the metaphorical sense, I have more of a street smart, less of a book smart. I got good grades because I worked hard, but it was a struggle. Nothing ever was, especially when it comes to mathematics and physics. Oh my God, I could not figure it out. So I was a little nervous coming into today's conversation, but you did a great job at breaking it down and helping me understand your mission and what you're doing. So thank you for that. Thank you for giving me the space to come on here and just chat with me. I mean, I feel honored. I think that I'll be able to look back and say, man, I got to talk to her early on, and look at her now, so that's pretty exciting. And I'm congratulations on being an entrepreneur and a successful entrepreneur. Keep pushing, keep doing what you're doing, keep innovating. To our listeners, my gosh, thank you so much for listening. Because of your viewership, I get to have these really neat conversations. I understand that today's conversation was a little outside of what we normally talk about, say pilot to pilot, helicopter wise. But nonetheless, I think it's super important, because I think the industry is moving in a direction where we're seeing new forms of propulsion. In this case, hydrogen propulsion, and such a neat thing to learn about. Just feel like I've had my mini little lesson of hydrogen fuel cells. I'm better now. So thank you, Dr. Anita, for coming on. It's such a pleasure. Where can people connect with you if they do want to connect and learn more about you, if they're interested in maybe talking about investing or looking at helping you grow your company through capital?
Yeah, so we're on LinkedIn. So I think if you go to Hydroplane, I should know our LinkedIn. I can give it afterwards. We're also on Instagram at Hydroplane Aero. We no longer use the other platform, and I think that's probably the best would be LinkedIn. And I mean, should I give you my? I don't know if I should give my email address out on the. Well, actually, they could email info@hydroplane.us.
Perfect. Yeah, it's completely up to you. Well, hey, Doctor, thank you so much for coming on. Inspiring conversation. Good luck in all your endeavors. I can't wait to follow along. I'm glad Jen reached out. Are you working with Jen on
Yeah, she
PR
does.
and things?
She's our communications person. Yes.
Yeah, Jen's great. So I'm glad that she reached out. Thank you, Jen, for making this, to MHM Publishing and the Vertical HeliCASTS platform. Thank you so much for allowing me to have this platform and this voice within this industry, and giving me the autonomy to have whoever I want on. So today wasn't super helicopter specific, but it was so aviation specific and to the future, which I think is so cool. So I'm just appreciative that I have that autonomy. And of course, to our sponsors, thank you guys so much for supporting the show. And again, Dr. Anita Sengupta, thank you so much for coming on today's Helicopter Podcast.
Thanks for having me.
Please stay tuned for a final word from our sponsors.
At Astronautics, we're aviation problem solvers. With over 60 years of OEM and retrofit experience, bring us your toughest avionics, connectivity, cybersecurity, and system challenges. We'll work with you to find an innovative, reliable, and quality solution. We turn problems into solutions. Visit us at astronautics.com.
Thank you to our sponsor, Precision Aviation Group. Mission-critical operators and fleet managers rely on Precision Aviation Group as a worldwide leading rotor and fixed-wing MRO provider. PAG provides tip-to-tail solutions in 4 MRO segments: avionics, components, engines, and manufacturing DER services. A single point of contact gives you access to over 150 million in inventory globally, 24/7. Just call 800-537-2778. Precision Aviation Group. Others sell parts. We sell support. Thank you to our sponsor, Robinson Helicopter Company, the choice for unrivaled safety and reliability so you can accomplish any mission with confidence. For more than half a century, Robinson has been at the forefront of the helicopter industry. From the R-22 to the R-66 turbine, Robinson makes helicopters accessible so more people can accomplish more missions. Climb higher. For additional information, visit www.robinsonheli.com.